Good day grade 10 students of Sullivan National High School. I'm Sir Albert Ramos assistant and today we're going on a journey to the heart of our planet. We're going to explore the Earth's internal structure, and along the way, we'll discover the different layers that make up our home. Imagine you're holding an apple. The Earth is kind of like an apple, but instead of a core, it has layers. Each layer has unique properties, and these properties are what make our planet so dynamic and interesting. Let's dive in. First, we have the crust. It's the outermost layer, and it's what we stand on. Imagine it like the skin of an apple, thin and relatively brittle. It's actually quite thin compared to the other layers, only about 5 to 70 kilometers thick, depending on whether it's oceanic or continental. Oceanic crust is thinner, about 5 to 10 kilometers thick, while continental crust can be up to 70 kilometers thick. It's primarily composed of rocks like basalt and granite, and it's where most of our planet's geological activity happens, like earthquakes and volcanoes. Now, let's move deeper into the Earth. Below the crust lies the mantle. This layer is much thicker than the crust, stretching about 2,900 kilometers down. The mantle is made up of hot, semi-solid rock, like a gooey chocolate chip cookie. It's not quite liquid, but it can flow very slowly over long periods. This flow is what drives plate tectonics, the process that moves the continents and causes earthquakes and volcanoes. The mantle is also home to the asthenosphere, a partially molten layer that allows the tectonic plates to move. Finally, we reach the Earth's core. This is the innermost layer, about 2,900 kilometers thick. The core is like a giant ball of iron and nickel, and it's divided into two parts, the outer core and the inner core. The outer core is liquid, and it's responsible for generating Earth's magnetic field, which shields us from harmful solar radiation. This field is crucial for life on Earth, protecting us from the sun's harmful radiation. The inner core, on the other hand, is solid, even though it's incredibly hot. The immense pressure at that depth prevents the iron and nickel from melting, even at those high temperatures. So, that's a brief journey to the Earth's internal structure. It's a complex and fascinating system, and there's always more to learn about it. Now let us proceed to the mechanical layers of the Earth. The Earth's interior is divided into several mechanical layers, each characterized by different physical properties and behaviors. These layers include 1. Lithosphere. The lithosphere is the outermost layer of the Earth and includes the crust and the uppermost part of the mantle. It is rigid and brittle, meaning it can break under stress. It varies in thickness from about 5 to 70 kilometers, with oceanic lithosphere being thinner and denser than continental lithosphere. The lithosphere is divided into tectonic plates that float on the more ductile asthenosphere below. These plates interact at their boundaries, leading to geological activities like earthquakes, volcanic eruptions, and mountain building. 2. Asthenosphere. The asthenosphere lies beneath the lithosphere and is part of the mantle. It is partially molten and behaves plastically, which means it can flow slowly over time. It extends from about 70 kilometers to 200 to 250 kilometers below the Earth's surface. The asthenosphere allows the tectonic plates of the lithosphere to move because of its ductile nature. This movement is crucial for the process of plate tectonics. 3. Mesosphere. The mesosphere extends from the base of the asthenosphere down to the outer core. It is more rigid than the asthenosphere but still capable of slow, convective flow. It spans from approximately 660 kilometers to 2,900 kilometers in depth. The mesosphere's increased rigidity compared to the asthenosphere is due to higher pressure at greater depths. This layer plays a role in the transfer of heat and materials within the Earth. 4. Outer core. The outer core is a liquid layer composed mainly of iron and nickel. It surrounds the inner core and is crucial for generating the Earth's magnetic field. It extends from about 2,900 kilometers to 5,150 kilometers below the surface. The outer core's fluid nature allows for the convection currents that generate the Earth's magnetic field through the geodynamo process. Now, let's see if you've been paying attention. Does anyone have any questions about the Earth's internal structure? Think about what we learned about the different layers, their composition, and the properties that make them unique. Maraming salamat sa pakikinig at mabuhay kayong lahat.